Problem 53, I guess that's in 12.6, asks you to find the moment of inertia about a laminar rectangle H by L, homogeneous, about an axis through its center of mass. Well, center of mass is going to be the center. So if this is L, and this is H, if you interpret the axis as being in the plane of the object, then you don't get a unique result. Okay? For example, if you do about a vertical plane, if L is bigger than H, then on the average, points and mass increments are further from the axis, in this case, for the vertical axis, than they are for horizontal axis. And if you think about what moment of inertia means, that means that when you sum them all up, you're going to get a bigger result for this axis than you will for this axis, much less any axis at any angle with the vertical or horizontal, or any axis that's not parallel to one of these. And so that kind of eliminates the possibility of a unique answer, although it'd be kind of interesting, for example, to figure it out for an axis that makes some angle theta, say with the long side. Okay, that might be an interesting problem. But what we're really probably talking about here, and the book isn't very specific, is about an axis perpendicular to the plane of the laminar region. So it becomes a matter of sample point out here at the distance from the center of mass. You've got to sum that up. It's reasonably straightforward. Once you have that picture, you should have no trouble doing it. It's just a matter of figuring out what symmetries. I had to think about it for a few minutes because I saw what you were doing, and I kind of implicitly assumed that the axis had to be in the plane, but it was clear it couldn't be. So after fumbling around in my mind for a few minutes, I said, oh, well, the axis has to be perpendicular to the lamina.